Hey everybody, Nick Fannin Steel with Timber Tiger Aircraft here. I just wanted to go through the tail surfaces with you today, give you a quick overview of how those are built, how they look, how similar they are to the original Ryan ST tail surfaces. As you know, our Ryan ST kit, replica kit, the STL, is very similar to how Ryan originally built their airplanes. Of course, we've made some changes for manufacturing purposes. Times have changed over the last 90 years. We have new technologies available. So we'll be getting a little bit into that as well. And this is a good case of things having advanced over the last 90 years. And this square gets cut out. This is actually a mounting plate for an electric trim servo. The trim tabs on the STL can either be electric, manual, or even one side ground adjustable and one side electric. That seems to be what most of our customers want to do, just because this trim is extremely powerful. So having one on each side, a tab on each side, isn't entirely necessary. This is, of course, the elevator. All of our ribs are stamped. We stamp these in-house. We do everything here in-house except for the metalwork on our cowls and wheel pants and stuff like that. That stuff we outsource. But everything else is done here in-house. This is practically identical to how Ryan built their elevators and tail surfaces in general. It's an aluminum tube spar, stamped ribs. Everything's riveted together with gussets here. The only change we've made really is adding a giant gusset here to carry the electric trim. So this is a very simple thing to get done and accomplished, but this is actually the more difficult part of the kit, of the entire kit. Why is that? It's because you have to do a lot of measuring to lay out your fixture on the table to position all these different things. That's why. So really, as long as you know how to use a tape measure and double check your measurements, this isn't really that difficult to do. Now, the wing, it's bigger, it's about the same, a lot of measuring, but our wings are now pre-drilled for all the fittings and stuff like that. So the wings even, and you can kind of see underneath the table here, I've got the wing drawn out. And it's kind of hard to tell, but yeah, that's as easy as the wings are. We'll cover that in another video, but honestly, for the wings, we mark the ribs, we mark just one of the spars, and that's it. That's all you have to mark out for the wing. We'll cover that in a different video. And then as far as the fuselage goes, the fuselage is a lot less measuring, and it's more of I don't want to call it pure assembly because it's not. There's still a lot of trimming and opening up holes, but everything's match drilled. It kind of just falls into place, and as far as where it goes, and then you work it from there. So anyway, that's why the stabilizers are actually the most difficult part of, in my opinion, the project. And again, it's not that difficult. It's just a lot of measuring for the layout. So you'll see some of these ribs here have flutes. We put those in to aid in the forming process. Once you get your tail surface kit, you will have to do a little bit of straightening of the ribs as far as just tweaking out little minor flaws. That's just how it is. When they get in a box and they're being shipped, sometimes they knock against each other just a little tiny bit. So just straighten those out. It's nothing ever major. It's always minor. These weldments, of course, we do all of our weldments in-house. You don't have to do any welding on the STL kit at all, unless for whatever reason you decide you need to. And again, any modifications to the kit is at the builder's own risk and really needs to be, I don't want to say approved, because the way we design the kit is how we really want you to build it. These here are fabric braces. These fabric braces prevent this rib from being pulled in when you cover this thing in fabric. Fabric is actually pretty strong stuff. It will warp parts if you're not careful with it, and with the design. So that's why we install these braces here. And Ryan had the same exact braces too. So the one thing missing from this rudder is the trailing edge trim tab, and that goes on after fabric covering. It's a simple manual tab, nothing big, nothing crazy. And on the prototype STL, which is now in North Carolina, that airplane never even needed that trim to be messed with. It flies like the airplanes on rails is how it was once put to me. And I'll tell you now, guys, the STL is such a sweet airplane to fly. It has been nothing but a pleasure to anyone who's flown it. Like any tail dragger, it requires your attention, but it's nothing crazy. With only 100 horsepower in the Rotax, we're cruising 97 knots true, believe it or not. So that's pretty good. So now keep in mind, you can also get big bore Rotaxes these days that are in the area of 120 horsepower, and that should really wake up the airplane. The airplane lands, it touches down right around 40 knots here in Colorado. And when Brooks was doing his initial testing, and you can look up Brooks Mershon's other videos, he's done a lot of flight videos, and they're a lot of fun to watch. But in one of his videos, he's in Boulder, Colorado, and he's indicating 27 knots, and he's got the power in, and he's just flying right on the verge of a power on stall and dancing back and forth on the rudder pedals with no tendency to drop a wing. So this airplane is incredibly forgiving in the air. A lot of fun. It has a nice cruise speed on minimal horsepower. It'll get up and scoot if you allow it to. We've had it to VNE. No flutter issues that we've seen. Now keep in mind, the tail surfaces are built just pretty much about how Ryan did them. And Ryan Aircraft, the original STs, Tex Rankin reportedly dove his past 200 miles an hour regularly. And as far as I'm aware, I've never heard of any flutter issues on those as well. So we've been incredibly happy with the performance of the airplane, and it's a beautiful flying airplane. So back to the stabilizers. I got a little carried away there. As you can tell, I'm passionate about this and what we do. It's a lot of fun. These tubes, this spar tube, this is the horizontal forward spar. This comes pre-bent from the factory. Okay, one of the things to watch out for when you're building this airplane, don't go and hog out these rib holes. Okay, this assembly is really sensitive to where this spar is, front and aft, in addition to where this miter is. Okay, if you have this tube an 1/8 inch too long, this thing's not going to fit. Okay, so when you're doing this miter here, creep up on it. Don't go all in and undercut yourself. Don't, or overcut yourself, I should say. Don't make it too long and assume that something's wrong. Okay, once you get that miter fitting properly, you won't need to open up these holes, but enough to just remove any burrs that are on the edge from manufacturing. All right, so as you can see, this stabilizer is not actually anywhere near done. It doesn't have the fabric braces in. It doesn't have the rivets in that go here into the forward spar. It doesn't get any gussets on the back, and that's no different than how Ryan did it. It's exactly how Ryan did it. The elevator, of course, does get gussets, and that's exactly how Ryan did it as well, although our gussets are shaped just slightly different. One change that we've made from the Ryan plans is this used to be a steel fitting. Okay, this is where the wire comes in, the tail brace wire. It used to be a steel fitting. The problem with the steel fitting is that it's real short. Okay, when we get that bending load from the downforce on the stabilizer going into this point right here at the wire, we want to spread this out as far as possible. So that's why we've changed it to aluminum, and it's actually a lot longer and a lot safer, a lot stronger. So now coming back to this rudder here, or the verticals I should say, we use a few different types of rivets in our assemblies. Okay, we use BSPQs, which retain the mandrel inside the rivet. And we also use in some places BSPs, which don't necessarily retain the mandrel. Usually they do, sometimes they fall out. So the difference, of course, if it's retaining the mandrel, it's more of a structural rivet. All right. Now there are some places on the airplane that, and not really so much in the tail surfaces, but there are some places in the airplane that we require solid rivets. We use solid rivets here, and that's what we ship out in the kits for right here, just because there's easy access to it, and it can be very easily squished with a hand squeezer, and also the solid rivets are much less expensive. Now, with that said, on the tail surfaces, if somebody wanted to come in and replace these two rivets on the rudder with BSPQ rivets, that's fine. That's totally acceptable. There's just not enough in the kit to do that, so they'll have to source some of those. The hinges, as you can see, everything we do in-house is TIG welded. Okay, a lot of manufacturers use MIG welding, and I'm definitely not opposed to that. Okay, it depends on who's doing the MIG welding. Certain applications, it's perfectly fine, but there are a lot of places it's not acceptable at all. So here we have our hinge barrels made out of 4130. Actually, the sockets are made out of 4130 steel. Hinge barrels are made out of mild steel. Why do we use mild steel in some of our assemblies? Well, the tensile strength of the 4130 isn't a requirement, and actually mild steel welds a lot better. In some cases, it's actually preferable to use mild steel, even in a structural application. Now, again, it depends on the numbers. It depends on the design intent and who designed that part. And, of course, they need to know where they're sourcing the materials from. There are a lot of bad materials out there. Our ribs are all 2024 T3 aluminum. Our spars are 6061 T6. And the spars, of course, come unfinished, just raw materials, except, of course, in the case of this guy here, which we bend it. So yeah, that's a real quick overview of the stabilizers. Very, very simple. Oh, forgot to mention, we do form the leading edges and trailing edges here in-house. So you'll have to do a little bit of tiny tweaking on these, but we do have some dies that we use to bend those, and that saves the builder a lot of headaches. So yeah, in the next video, what we'll cover is probably going to be the wing layout. We've got a wing build coming up here with a local builder of ours. And we're excited to show you how the wings go together. So if you have any questions, as always, reach out to us at Timber Tiger Aircraft. We're very, very easy to get a hold of, even on weekends and evenings typically. So if you have any questions, let me know. I'm happy to answer them. And until next time, stay safe.